is we now are, you should have now created an EDA. And we said for those that were there last session, we said the objective of this is to do an EDA. And the main idea here is that it's a loans, a loans initiative. So what are we going to do? What's our approach? Our approach in this is to do data pre-processing. This will include creating a data frame, loading data. Well, we're not going to do the data dictionary we did it last time. It's an easy step. So when we create the data frame, the same method that we do there is the same that we're going to be doing on this. So we're not going to focus on that. We're going to do missing data detection and treatment. How we're going to treat? We're going to observe outlier detection and treatment, as well as feature engineering. We're going to do some feature engineering, but we're going to be doing some. So we're going to do univariate analysis. Uni is we're going to be focusing at the variable at the time, and then bivariate is we're going to be looking at two variables or features, and multivariate is going to be two or more. So we're going to be looking at the relationships that are happening within that, and we're going to be looking at the correlations as well, and we're going to look at the top 10 most correlated features. We're going to look at the conclusion, and we're going to look at recommendations as well. So for everybody that is, I'm going to copy this code into the chart because I think not everybody has this. So while you are pasting this on your notebook, what does this code do? So what we are doing here is we are importing libraries. First of all, we're going to import NumPy as NP, pandas as PD, matplotlib.pyplot as PLT, and then Seaborn. What these libraries will enable us to do, basically what we're going to do. So just copy and paste this in your code and make sure that it's in code format. It's not anything else. It's not Markdown or NB converter or heading. It's in a code format right there. So once you've copied that, you can shift enter, or you can put your cursor in there or click run. So if you click run, it's gonna run and it's gonna display on the next. It's gonna display the next page. Here we are setting options, what we should view and all that stuff. And here we are suppressing errors, Python errors. And I'm gonna assume there is no error, and we're going to proceed to the next. I will jump this. If you remember, this is when we upload, there's a separate file for the data dictionary, but that's for the columns. I'm not gonna get worried about this. Why? Because as you can see here, when we upload the next, when you upload this file here, it has the columns of that. So anyway, how we're going to create a data frame called data, and you can code along, and then we're going to equate that we're going to call this function just to make it easy for everybody. So PD is, as you remember, is the pandas function that we had. So PD has a few functions. If you click the tab, it's going to display quite a few functions that you can call. And the one that we need in this case, we want to be able to read a CSV file. And how it's done, it's basically like this. And then inside the code, we're going to put the name of the file, and the name of the file, it's application. So I just clicked A, and it displays the name of the file. So the reason why this is possible is because the files are in the same folder. So if you have those files in the same folder as this notebook, then it should be able to recognize the name of the file. And then when you run, it should be able to run successfully. And how do we know that it ran successfully? We can go and say data dot head, and if you do that and run, it's going to, if you don't put anything inside, it's going to display the first 5 lines, the first 5 rows of your columns, and they are the first 5 rows. And then if you want to, the other thing to do is you can use the sample function. In this case, I'm gonna say data because I've renamed it from df to data. If you run this, and n is the number of rows or the number of data points that you want to see, n is equals to 20. If you don't put anything in there, it's going to, by default, it's going to display 5. In this case, it actually displays 1. So what you want to do is you want to put something in there. So we're going to say 50, and then it shows 50. So what you are interested at doing is you want to know what the shape of the file is. So data.shape, and let's see what it shows us. So it shows us the rows. And guys, please feel free, if I'm running too fast and you are behind, please feel free to paste on the chat or to talk simply with on your mic and let me know that I'm running too fast. So what it's telling us is, hello?
Yeah, so you are running a little bit too fast for me. So I'm still stuck on loading the libraries. I seem to be getting an error with the, loading the pandas. So, and because of that, I really can't read the CSV file. So I'm getting
what error are you getting?
Let me just paste it on the chat.
Okay, cool. All right, cool. While we're waiting for that, so what it's saying, the file has got it's about 300 300k rows and about 122 features. So we can just go and see if this is indeed correct. It is mostly correct. So if you go and check the rows, that's the first one. And if we scroll to the right, we can see it's got quite a few rows that it has right there. It's got quite a few rows that it has. So what I'm going to do also is, for the benefit of everybody, I am going to share these. I'm going to share this file with everybody, the one that I'm working on, so that you can come back and work on it. Kippy, I don't see anything on the chat yet, but then we're gonna proceed so long. So that is the shape. It's 122 rows. So pretty much it's a very big. Our data frame is very big in terms of the length of the columns and the breadth of it in terms of the rows as well. So it's a very big file. So what you can also do is there's this function called dtab. So what you typically do is that it's got autocomplete. You just, if I type DT like so and type the terms function, it completes for me. So what it tells me, pretty much what it displays is, it tells me what data types I have. So that is, you can look. So what I normally do is I write my observations at the top. So I've got integers, int64 objects. My object is typically your categorical variables. Integers are number columns, and then your floats are basically numbers such as currency with floating points at the end. And is there a question, or I see? Oh, there's people dialing in. Cool. I've added I think Choshi and Philip and Chloe. Welcome, Philip and Chloe. So going in. So the next thing that you want to do really is, remember we said we're going to be looking at missing values. And there's missing values come in different shapes and forms. So what we are doing here is we're going to be using a function called you can use different functions here. I'm just pressing Oh yeah, it won't do that because I'm not using the correct data frame. I've changed it. So there's two functions that you can use. There is NA, which is now, and also is null. I prefer to use is null. And what you want to do is you want to go and get the sum of all the columns that are null values. And what you want to do also is you may want to sort values as well. Sort values. And you want ascending. I want to ascending, and I want to set this to false. If I've got that, it will complain if I haven't got it right. Function object has no sum. Oh yes, I know why that there's a problem there is because it's not, it's a function and I defined it like that. That should be fine. False is not false. I think it's a capital F. There we go. So what I've done there, pretty much just to show you the difference quickly. What I've done there is this function still works. So it shows me the sum for each of this column. It's going to show me the data points, the sum of all the data points that have got missing values. So ID has no missing value, it's 0, but there are some that I've got. But if I want to sort them, pretty much what I want to do is I want to sort and I want it to give, show the ones that have got missing values. So all these columns that you see have got missing values in ascending by weight, basically from the top most one to the little ones. So what we pretty much want to do is this, as a rule of thumb. So I know in there what I'm going to do. We have lots of missing data points as part of our EDA. We will further explore if they are if these are missing randomly or as a result of a typo or data entry or errors. We will follow the following principles. If the missing data is greater than 10% of our total data points, we will delete that. So if you've got data, so we know the total of our data points is over 300K. I think it's 3 or 7K. If you look at those data points, all those data points that have got more than 30K, 30,000 missing data points, we are going to get rid of that. So this is 96K, we're going to delete 60K, 40K, 41K, and all that. So basically, all these rows that you see here, if we're using this principle, we're going to get rid of that. That means, remember when we spoke the other time, we spoke about data has got missing, data has got information and noise. This means that our data has got a lot of noise on some of these columns. So we're going to remove this, we're going to remove this, we're going to remove those features there. That's what we're going to do. However, if it's got less than 10%, if the data has got missing less than 10% of the data points, we are going to impute that data. So we're going to create, that's just a rule of thumb that we use in data science to determine whether should we keep the data, is it corrupted, or should we delete? So in this case, it's safe for me. I know it's easy to delete. In other cases, it's not as straightforward, so you may not delete the data point. And then you also indicate your assumptions there. Though we are not required to model in this case, but simply EDA, we will assume features with missing values as noisy, and we reduce those as part of complexity reduction, which will assist us in multivariate analysis and correlation plotting. So I'm just indicating that I'm going to remove that. Then the next part, you've seen, we're going to create a second data frame based on the second data point that you guys just downloaded, and that is the previous application file. So you already know how to create the data point. This is the name of the data point, and we're going to use the pd.read CSV, which we've used already, and then we're going to pass the name of the file, the CSV file, in there. And then the next line, we're going to, this is the same. That one was a sample file. We're going to say head, and we read the top 10 files of, okay, that is not going to, yeah, it was gonna work, took long. We're going to read the top 10 files, so we're going to run that very quickly, and then it returns the top 10 file. Alternatively, what you can do is what I had done, which is you can use the sample. So when you use the sample, it goes to retrieve 10 random files. So you can see the IDs are in a randomized order, so it retrieves. I prefer sample because it retrieves the files randomly, and it can easily show me where there's any missing files, etc. So I'm not going to look at the shape. It's the same thing. You guys already know how we do the shape. Again, we do the same thing for this file. We check now for this new PDF based on the previous application file. Is there any missing values? And also there is missing values. We've done that with the first file, so I'm just walking through to that. So what we're going to then do is we're going to merge both files now. So we have two data frames. We've got, we've got two data frames. We've got data, and we also have the one that we just created now called PDF, right? It's just a name, a lazy name that I gave. The P stands for previous data file. So what we're going to do now is we're going to use a merge function. We're going to use a merge function based on our data frame using pandas, and we're going to call that merge. And we're going to we have one here. We're going to do on the data file, the one that we created, the data frame called data, is gonna be on our left. On our right, we're gonna have the PDF one that we just created now. I just called it PDF, just lazy name there. And then we're going to do a left. We're going to do a left on using this key called SK. It's a referential key. It's an ID. It's like a unique key, like a transaction unique key, that a transaction ID or an ID that belongs to a single row. It's unique. That's the one that we're going to use. And on that same file, if you check, it's available on both the previous file, there it is, and also on the other one as well. Just for reference purposes, I'm going to go on this side quickly. So there's the unique key. So that's going to be our unique key that we're going to merge using. And we're going to run the merge very quickly. We're going to run the merge. Just make sure that I've got all the names correctly. And we're going to view a sample of the top 10 files. So this should take a little bit of time to run. Once it has run, it's going to return something, because these are two big files. So how do I know that my Jupyter is still running? There, when the black dot is, when there's a black dot there, it's still running. When it's clear, when it returns something, whether it's an error or it's an output, that box or that circle there becomes white inside. So that's how I know that it's and if you highlight over that, it tells you that it's idling basically. So we now have our third data frame, and you already know we can then look at the shape of the data frame. The data frame now has got 141K, and you would understand that I've matched two files using an inner join in this case. So an inner join is going to take the files that are common on both sides, and it's going to leave out files that are not common on both sides. So our new data frame has now been reduced from the first file had about 307K. The second file had, I can't remember how many it's there. There it is. It had 167K. The new match file that we have now, if we look at the shape, it's got 141K. It's because we've used an inner join. It only looks at the, it takes, but then in terms of our columns, we now have got more columns. What is happening is it's taken columns from the left and columns from the right, and we can see that our file has got, it's become bigger now, basically. So I just want to repeat again, if anything is not clear, feel free to unmute your mic and do ask if you have any questions, or you can type on the chart if my pace is a bit fast. I know I want to get to the interesting stuff. So looking at the data types, this we have done already. And looking at null values, we still have got null values. We're going to use the same principle, so I don't need to dwell much into this. So the next thing that I do, I check for duplicate values. Don't worry, we get the recording. Awesome. So I check for duplicate values by using the duplicated function, and I say return anything where there's any duplicate. That's what this code is going to do. Return anything where that is the case, and also give me the sum of that all, and then I use .sum again. So what is the difference here? Let's just run this quickly and see what this does. So this is just going to give me sum of any duplicated values. So it's still running. But when I do .sum, so what it was going to do, in fact, I can do that here. That would make it no, the duplicates channel are based on the rows. So it's gonna use the ID, it's gonna use the raw ID, and it's gonna check if there's any ID that is similar, and it's gonna return that. So there might be some values in the columns across in the same column that are duplicate. That will be your mode value that have got the most frequency, and same values might be shared across different columns as well. So those, we don't consider those as duplicates. So it checks based on the rows, not on the columns. All right, so that's what it's gonna do. And then what we then do, remember, our file is big, so we are cleaning. This is part of cleaning the data. Remember, we are doing pre-processing. We are trying to check, do we have any files that, we're trying to reduce our data frame to remove any redundant data, any noise that we might have, so that we are left with a very clean data set that we can then do further analysis on. So what we are doing here is dropping columns to reduce feature dimensionality. So you'll remember that here we have these columns here that have got lots of missing values, and these missing values are more than 10% of the population. The population now is 141, so 10% is at 14,000. So any field that is greater than 14,000, this is 16,000, we're going to delete. So how do we do that? This is what exactly that. So we're going to use a drop function, and then in the drop function, we specify the columns, and we were going to do a very interesting thing here. We're going to use the indexes of the columns. So we say, how does the indexing work? I'm going to explain that very, very quickly. In Python, the indexes starts from 0. So this is our match file. This is the index of this column is index 0. This is the target is 1, 2, 3 until we get to the very last one that we have, which is this one. That's going to be index 150. this is going to be index 157. If yeah, it's going to be index 157. So what I'm doing here, in simple terms, I'm saying starting from index 50. So I did some checks somewhere to say which index are those columns there. And then I discovered that, okay, it starts from index 50 to index 100 on axis 1. What is axis 1? Axis 1 is the columns, axis 0 is the rows. And then in place true tells Python that go and drop those columns. So I run this and it has executed, as you can see. And when I check the shape, it should be, we should have moved from 158 to now 108, meaning that I've dropped 50 features. And we can go and quickly check that, by the way. We can do meshed.head and then we can see we've dropped quite a few. As you can see, the scrolling is anyway. So we can see the shape has changed there. So let's move forward. And then the next thing I do, I drop also other columns from column 102 to 108. And the same thing is going to happen. It's a drop. And then, so I want to skip this, and I will tell you the reason why. As part of preprocessing, I'm doing the same action here. I am eliminating columns that have got missing values that are above, with a count that is above 10%. So if you allow me, I'm gonna go. And what you're going to notice is every time I drop, I check the shape to ensure that it's got the drop has worked. And then the next thing is I'm gonna check if there's any missing values, and then I keep on iterating and do the same thing. I can do this using a loop for any advanced beings with us here would appreciate that. But I did this to make sure it's neat. I'm not missing anything to avoid doing any rework. So I'm doing exactly the same thing. So I'm going to, as you can see, they're becoming less and less. I'm now left with 88. And I'm just gonna, I was going through doing this methodically, just going through the same until I am happy I know what is going on. So now we're getting into the juicy part of this session. And there is a function here that I want to copy for those that are coding along. I'm gonna copy and paste it. I'm gonna copy this, not that. Okay, paste it here. Paste. It's not pasting on my side. I don't know if it's because I don't know if Zoom chat has got a limitation on the number of text that I can copy and paste. But failing which, I'm just going to proceed. Okay, I'll just explain what I'm doing here. So I am defining a function that's going to accept numerical columns. It's going to treat numerical columns only as input and return the box plot and histogram visualization. So this is a histogram slash box plot that I'm going to do. It's basically going to visualize my histogram and my box plot. It's a self-defined function. So there it is. I'm defining it. It's going to accept the feature, and I'm defining the size, blah, blah, blah. It's self-defined. I don't need to go much into that. The next thing that I do is I'm creating another function again that's going to draw a percentile bar graph. And you're going to pass a function, and it's going to draw a percentile bar graph. And so we're going to start with the numerical features. I'm going to start with all those integers. And the first one that we're going to look at is the target. So we can see that the target, the unique function, it returns the unique features that are available in that, unique values that are available in that column. In this case, this is a binary. It's either a 1 or a 0. And when I check at the columns, obviously there will be 2. And here I'll try to check the distribution of both by using, I'm using this function called value count. And then I say I specify that it should normalize. So what that does, basically, if I show you, I run this, it when I say normalize, it indicates the percentages. What makes the, will it make a difference if you use matplotlib or you should only use histogram? Or so that's a great question, Kataho. I am using matplotlib, and I just used a customized function. So in matplotlib, we've got a specific box, a box plot visualization, and we also have a histogram. So that function that I've created is going to merge a box plot and a histogram, and it's going to display that as one. So that's what that function has done in simple terms, to answer your question. So what I've done here is I want to indicate this as 100%. So I'm going to, in percentages terms. So you can see that 0 means that these are new applicants who have not defaulted. And their distribution is 91% in there. And you can see it here, the distributions of the ones and the distributions of the zeros. And what I've actually done is, so to Kataro's point, here I've used the histogram via matplotlib, and it has done that. I mean, it's nice. It shows you the ones and the zeros, but using the percentile bar graph, this is the difference that it does. The ones, customers that have defaulted are 8.7%. Those that have not defaulted are 91. So in terms of our, if you remember, one of the things that we spoke about last time was to say, you should be aware of the biases in your data. You should also be aware of the variance in your data. So what this is telling us is, in our data, we've got a lot of customers, the majority of our customers, over 91%, are those that have not defaulted. And only a small number of them are those that have defaulted. Remember, the objective function here is we want to create, at the end of the day, it's not the purpose now, but at the end of the day, you may want to create a data model that is going to help the business know if they give credit to a customer, is that customer likely to default or that customer will not default? So this is a bias that you need to know. And this is telling you the speed of your distribution. So I'm emphasizing on it because it's a very important part. In fact, as a general rule of thumb, stay away from pie charts, but I used one here. I think this is the first time I used a pie chart using Python. Stay away from pie charts. They are not pretty. Rather use bar graph or histograms. They're better to understand. It can represent your data very, very well. So the next thing that we do is we do a describe. What a describe does is it's a function in pandas. It gives you the five point number summary. What is the 5-point number summary? That is the mean, the max, the mean value, the median. It's going to give you the mode as well, and it's going to give you the standard deviation as well. That's what it's going to give you. So as you can see, you got the count, the mean, standard deviation, the minimum number, the 25% quantile, 50% is the mean, the 75% quantile, and then the max. The 50% is the median, rather, not the mean. The mean we already have there. So that's the median, and then you got the max number that you have. So what this function does, and here I use the transpose. If I don't do that, this is what it's going to do. So just to show you, it's going to put the columns on top and then it's going to put the other way. So what the transpose basically just changes that. So I prefer to look at it in this function. So for all the columns, all the numerical columns, it's going to give you all those values in there. So I like this because it's easy to read. So that's what that shows you. So basically, it's giving you insights into your data. It's telling you about the statistics of the data. Mind you, data science is using a lot of statistics. I'm just checking here, Mklokwe. Time-wise, we've got a minute to go. I don't know if do you guys mind if we push for another what, 15 to 30 minutes? Is there any objection if we push into that?
Hi, I would really love to stay because I actually caught the session a bit later. Yeah, but I think 15 minutes from my side can do.
Okay, cool. We can continue. Okay, good stuff. Let's continue. I'm gonna stretch it to past. If you feel you need to drop off, feel free to drop off. But at past, I'm gonna stop. So anyway, so now the objective for EDA, if you remember, the reason why we're doing all this is to allow the data analyst or the data scientist to be intimate with the data. And in this particular case, this is a case that we've chosen for supervised learning. So you are getting to know the data intimately. Even if you're doing unsupervised learning, you will still need to understand your data. So EDA really is important either way, whether it's for supervised or unsupervised. If you need to understand your data, this is one of the most preferred method of doing it. There is other ways of doing the same thing that I will not cover today, but I will cover this because this is the most preferred, the most professional, the most preferred method of doing it, of getting to know your data intimately. So the next thing that we do is we started with the function with the feature target, right, with the column target. So the next one that we're going to do is the count, the number of count for children. So when we use unique, you've seen this function again, we check what is the unique count for children. We see that there's these different groupings that we have, 0, 1 until 14. So when we check, as you can, it's the count, it's 15 counts in there. So what that tells us really, okay, this was supposed to be for that, no worries. That was supposed to be, this was, I was putting a narrative for that. I think it overlapped there. So this is for that. So what I'm just moving forward. So in terms of the count of children, I then go in and check what is the distribution like for children? Which groupings of children accounts for the most, or how is the distribution like? And again, I'm using the values count, and I tell Python normalize that, set normalize to true, and what it does is it gives me percentages. So as you can see, 71% of the population that we have don't have kids, or they've got 0 kids. That's a very insightful step to look at. So anyway, we can plot this, and I always note what I'm writing. So we plot this I'm going to use a histogram first, and I plot this, and then it tells me exactly that's the grouping. Those with 0 kids account for the most in there, but I can also use the self-defined function that I created. And you will see that it starts telling us some new information that we didn't have using a histogram. And it's, so I call my function that we've created earlier on at the box plot. I pass the children feature as using the dot function under the data frame that I've created, and it shows us that the concentration of our histogram on our box plot is around the 0 point, and there it shows us again on that. And then there's minor ones on the other side. So this is very important. What it also tells us is there are outliers in our data, with this being an extreme value. So potentially, this is maybe a family that has got more than 14 kids. If you're looking at this, so there are family where there's more than 14 kids, and that's very important to notice. Mind you, we're going to detect outliers as well. So, and then I use the percentile just to state the same thing. So I'm going. So what you're going to see is, as we're going in, knowing each and every column, we're going to be repeating the same steps, but it's giving us different data because we're looking at different columns, and we're learning on the data. And as we are doing that, we are noting the observations on the side. I would emphasize this, do that. And how we're doing this, we're using Markdown code there. So the column will be in a code format, just for the benefit of those that may not know. And in order to change it, you just put a cursor in there, and then you apply Markdown. And then when you Alt key, it then changes that. Python knows that it's Markdown code, just like that. So I would encourage you to note your observations in there. And when you have questions, like in this case, I said, we would like to explore this further to gain more insights and are interested at knowing what is their gender, age, employment status, family status, years, employed, and more. We would also like to understand the same about those with 2 or more kids. Is there any correlation between the number of children and credit? Is credit given based on the number of children? You know, so as we see this, we are asking ourselves a lot of questions, and it's going to come in handy. And then the next thing that we do, we noted our observations. We go to the day back is basically the days since you were born. And then you'll notice something very interesting here. When we pick up unique values in there, we realize that some of these values, there's quite a lot of them indicated by the dot, but you can notice that they've got negative values, negative signs. Is it possible that bad days can have negative signs? This is probably a typo. So we're going to impute this. And how we impute this, so we'll impute that in the following steps. And there's different ways of imputing this. But when we go and look at the number of unique values, we notice that those are the number of unique values. And in this step, we're going to use the absolute function on the date of birth. We say, on the day's birth, we say, Python, go and apply the absolute value on this column and return to us the new values. All that it's going to do, the absolute value function is, if you've got -10 and you apply the absolute value on, the absolute value of -10 is 10. It's not, so what the absolute value function is, it treats the negative values. So that's what we do there. And then when we enter, and then we run this again, you notice that the negative values are gone. So that's how we treat, that's how we have treated the negative values. And then we then use our self-defined function, and then we look at this, and then we notice something. We know as common knowledge that date or age or date of age in general follows a normal distribution, and you can see everything is centered. The distribution flows. It's not a perfect normal distribution, but the mean and the median are at the center, so we can almost say it's a perfect bell curve. And then we are allowed to do that. So here I find I go, I get the mean the value, the mean value, and then I get the median, and then the mode, so that it can enrich my narrative. And I do indicate that it's I don't think I did indicate it in this case. Oh yeah, there. As expected, client age follows a perfect normal distribution. As can be seen, the mean and the median are equal in the above. So these are some of the narratives that you do. The next thing we come to days employed. We notice the same thing as well. They are negative values, and as we know, your days employed can never be on a negative. So probably it's a typo that happened, and then we're gonna do the same thing. We use the absolute function, and it's gonna return positive data. And then when we plot this, we get something very interesting. Notice something there. The majority of our data set seems to have days employed under, closer to 0. So what this tells us is the majority of, I think in this case it's about 93% there. Well, it's I didn't normalize this, yeah. Okay, so the majority of our data points are concentrated towards the 0 point. So it tells us that of those people that come in and apply for credit, most of them are newly employed people. So, and then you note that, and then right in there. And I believe that you are basically seeing the trend. And then we look at the ID published on the data dictionary is when was how many days since the person has got their ID number. And we can see in this case, we notice this is a right skewed distribution. If this is the center, this is the mean, this is the median. Most of the data points are skewed towards the right. So what this tells us is of those people that come in and apply, there's a large concentration of them who are actually whose dates since they got their ID is lies in this region. So these are pretty much older people. These are pretty much younger people. So if you look this and that's going to come up with a very interesting. I would be interested in knowing the relationship between these two and get the distribution. But anyway, let's continue on. So pretty much what you are doing, we are exploring each of the features. The next one that we're looking at is a flag for mobile. Does the customer have mobile? As you can see, it's only one value in here. It's and on our data set, it so happens that almost all 100% of the data set has got a cell phone. So this is a very important observation. It means that our customers have got cell phones. It means that we can contact them. Notifications can be sent on their cell phone in case we need to send notifications, etc. And then it so happened that we had other similar flags as well, such as the employee phone, the work phone, the account phone, and all that. Do we still need to use this for our analysis if we know that 100% of our employee base of our data set have got cell phone? Potentially, we may want to delete some of these because we know that as a method of contact, that's what a cell phone is for. We can, if all 100% of our data set have got cell phones, we might as well contact them using cell phones as opposed to contacting them. Why do we need their work phone number and all that stuff, So it helps you to reduce complexity. And I think I went on and checked on this, and I ended up concluding that I'm going to delete that count. So that's then in here we were checking for platform for mobile. I can't remember what there's count. Oh yeah, this is, we were asking them the preference, do you want to be contacted via mobile? And again, we already know that 100% of our population has got mobile, and in here, none of them opted out to be contacted via mobile. So already you can determine that a mobile phone is the most preferred method of communication. That's a very key insight to know in there. And here we check for a phone and all. And I think, yeah, here I at this stage, because I went on and explored all those, I explored email. As you can see, majority of the population here doesn't have email, for instance. And I explored employee phone and all that stuff. So I ended up concluding communication is very key, and we have discovered via the above 100% of our customers have got a personal mobile phone. We also learned that 92.75 don't have email or opted not to be contacted by email. So therefore, I decided I'm going to reduce this. It reduces complexity. I think I've nailed the point in there. I'm going to move quickly to, and then you do location. You look at the location data set, regional rating for the clients, and that's what it's telling you. 75% of them, it's a clients based on this region. So the rating, 75% of them have a rating of 2. Remember, we've got the data dictionary, so it will explain what the column is and what it means there. So I want to skip on this. If you are following, we're pretty much exploring and learning our data. We're going through the same thing. You look at the hours. Yeah, this is an important one that I want to get into. So the hour application process start. This is telling us which hours in the day do we process the most applications. And as you can see, this is midnight, 5 o'clock in the morning, and etc. So what we've seen here is it seems like there's a peak around that 10 o'clock. Majority of the applications that are processed for loans are processed at 10 o'clock, followed by this will be 9 o'clock, this will be 8 o'clock, this will be 11 o'clock, this will be 12 o'clock. So the mean is at the median is the mean. The mean is at 12 o'clock. At 1 o'clock, there's still quite a bit, but you can see from this time, so there's a drop. It's a perfect normal distribution, but these are the peak times when customers prefer to come in and apply for loans. How is this important? This you can use as in your recommendations or as in your conclusions to say that it means that based on the channels that customers, as we're going to learn in the coming below lines, customers prefer to come in and apply during these hours. It means that we should be operating at full throttle from a sales and systems availability point of view at this point. That's just an insightful stat that you find, and I think that's what I've noted in there. Region, this is a flag for region where they don't live and all that. So there's quite a few. I think I'm going to skip this one. You can go through it as when you've got time. Then the next one that I want to look at is the documentation. So we got flag for documentation. We've got different types of documentations that we have from 16 documentation 16 to 21. And what did I do? I just want to check something quickly. Why did this surface here? That seems to be out of place. Okay, that seems to be out of place. I was still filtering through the regions there. I put that in the wrong place. And then now the hours where applications are processed based on the previous data set. It seems to follow the same type of distribution as the previous one. So that's very So it's telling us this consistency, there's predictability on our customers in as far as when do they come into the branch, or when they or when do they apply, or in terms of their loan applications, based on what we know on previous data and what we have seen on the current data. There is a predictability there. So we can say for sure that these are the peak hours when customers prefer to come into the branch, and our system should be up, and we should have salespeople in the branch. And I was looking at that. I'm just going to skip through the number of days that it takes us to make a decision to approve a loan from the time that the customer has applied. As you can see, we've got a left skewed distribution closer to the 0 point, not much at day 0, but from day 1, it seems as day around there. I think I found the mean for this to be day 245, I believe. I calculated the mean for this. So what this is telling us is, it is taking us less than 500 days to approve a loan, either in the affirmative or the negative. So the question then becomes asked: is that acceptable? Is that a good enough time? If a customer comes in and apply for a loan today, is there a reason why we can't give them the loan today? Is there a reason why we have to wait for such a very long time to approve that? So you can note that and give a recommendation, make some suggestion based on what you're going to find. So I'm going to skip, and this is now the part about the ID numbers. So I think I used a for loop for this to go and check the distribution for the different types of IDs. I discovered that ID 6 has got one of the largest distribution, I believe. Not ID 7 has got the largest distribution in terms of the volumes and all that. So in this case, basically what I'm trying to do here, I'm trying to see which of these documents are relevant and which are not. And I may, based on the above, we notice not all the documents are submitted with the same distribution. Thus, we will set a cap for a minimum of 1,000 documents. So I established that rule. As such, the following will be dropped. So I said these following documents are going to be flat. So pretty much there is a 0 or a 1 flag that is set for a specific type of document. For document type 6, we've got this much as no and this much as yes. So it is above 1,000, we're going to keep. This one is below 1,000, we're going to drop, etc., etc. And then I reduce complexity. I apply the drop function in there. I'll go and drop those. I think you've seen this already. How do we drop? And then now the next thing that I do is I process the float variables. But I'm gonna go quickly on this. It's literally the same thing. I'm intimately knowing my data. I'm using my user-defined function. I'm gonna skip this quickly. And then we're gonna look at the bivariate distribution. Now we come into the bivariate variables. And these are the bivariate variables. Now we're going to create a list of these and do some analysis, just as we've done, just to understand them. For gender, for instance, we realize that majority of our population is female. That's a very interesting from a bias point of view. So, and then about 55 of them are unidentified. And then when we look at the contract types, we realize majority of it is cash loans, followed by revolving loans. So for revolving loans, we don't get much there, but for cash loans, so this tells us majority of the customers that are applying are actually applying for for cash loans. And you can do the same thing for cars. Majority of the people said they don't have cars. Majority have cars. How does owning a car affect your loan application in the affirmative or in the negative? You do the same thing in terms of house ownership, reality. Majority of the people own houses. How does that impact their loan application? And then you look at in terms of what type of house are they staying at? Majority, oh yeah, this is when they visited the branch and applied for a loan, who accompanied them? Majority were not accompanied, followed by those who were accompanied by family member, followed by those who were accompanied by a spouse, and then those by children, and. This tells you a little bit about where they come from. And then when you look at income type, what type of income? Majority said that they are working, and followed by those who are commercial, they own their own businesses, and then followed by pensioners, state servants, unemployed were less, students. So students, we've got 24 students in our application there. And then those in maternity leave, it's about 16. That's a very interesting piece of step. And then you do the same thing for education. Majority of them have got secondary education, followed by higher education, and then incomplete higher education, and then lower secondary education. Those with degrees are the list. And we can already, it will be interesting to find out the relationship between education and income, for instance. That would be a very interesting one. And how does that affect your loan application? So I want to show you. So what we then went on and do is go and visualize that. We've now put it in a nice table. We just go and visualize that so that we can see it quite nicely. And I'm gonna, and we see the suit type, all of this, and it's telling a story. Income type, 51% are working. We look at educational level. We've already seen this, and then we do that. Now the question is, after we've visualized, this is now the hours in the day. If you remember, now these are the days of the week rather, where application processes are done. We see Wednesday, Monday, Wednesday, Tuesday, Friday. Tuesday seems to be the day where customers come the most. That's a very interesting one. This is based on your application, based on previous application. It's the we see that there's a uniform distribution across except for Sunday. So there's no differentiation based on previous data. There was no differentiation, but we noticed that based on new application, Tuesday seems to be the most preferred. We cannot afford to be down on a Tuesday. Otherwise, Wednesday, Monday, and Thursday pretty much have got a similar distribution. So that's a very interesting one. So now the question is, what is the relationship between these features? And then we're now going to look at multivariate analysis. And this is still using a percentile graph. I'm going to scroll through quickly on our EDA. This is on portfolio, which portfolios is used the most, which product is used the most. And I'm going to scroll through. And then I used a peer plot. A peer plot, basically what it does is it goes and gives you a summary of, in this case, I preferred the first 500 columns. Just give me an idea of which features are mostly correlated. You can see this feature here. There's some features here with strong correlations there, and then some features, this weak correlation there, and all that. So it's just giving me a synopsis. You can see a strong correlation, some no correlation at all. and all the stuff. So this is just giving me a high level idea based on the first 500 rows. So now I'm going to use a box plot, and I'm going to compare a numerical variable, and I'm also going to use a third feature called the U, and I will show you in the coming some of them to see. I also pick up in some of them there's outliers and all that. So I describe what I'm seeing. I'm gonna pick up an interesting one where I used there. I want to look at gender and credit, and I want to look based on those who, based on product combination. Of those males or females that are given credit, what do they go and buy? Which product do they prefer? Is there any differentiation between males and females in as far as their credit and in as far as what they go and buy? So how I look, so this will be females, this will be males, and that the different colors is product combination. So if you look at this one, for instance, how is this for females different for males? For males, we seem to have, so that would be your median. It seems like we have, males seems to prefer this product. And which product is that? That is point of sale either without interest. So that's how it was labeled. Males seems to prefer this product versus females. For females, we don't seem to have that. Whilst on the other hand, if you look at this product, it seems to be preferred across males and females. The distribution seems to be similar. So you pick up any that are different. If you look at this one, which is cash sell low, that seems to be preferred by males than it is by females, for instance. Whilst if you look, which one do females prefer most than, I'm trying to pick up one. I don't seem to be any. So these are, so we can use this information to say, okay, we know that females females who get loans tend to buy this type of product, and we can use that on our analysis, and we can use that as a recommendation as well. And then the next thing that we look at is for all those customers that default, right? And those that pay, so these are the ones that pay without defaulting. These are the ones that default. Of those that are given credit, how do they, which products do they prefer? Do we see any differences? Do we observe any variability between those? And from what I can tell, it doesn't look like there's much variability. And you can do this for, in this case, we're looking at credit for previous credit based on target, and then you're looking at across product combination. Can we observe any difference? And in this case, it seems like there's a difference, and I'm aware that you cannot see. But for this product, which is cash street middle, it seems like for those customers who pay without any default, there is a huge spread on that. There's a difference between those customers that don't default and those customers that do default. And we also observe, based on this, which is what? It's cash sell low, we observe the difference as well, and we observe the outlier for this product as well. So there's differences there. And then we can do the same thing for you can check for correlation between goods amount for goods price, where people spend their money on which goods, and the credit. So of the credit that they were given, did they go and buy goods? And there seems to be a very strong correlation in there. So we know that these customers that are borrowing money, they are going to spend that money. that is very important because we also know that not all customers that borrow money actually do go and spend money. Some of them can leave it dormant. And from a financer's point of view, we know that in those cases, we're actually losing money. We're losing money. We're losing income as a financer, as a loans provider, because those customers, we're not going to charge them anything because they're not using the loans that we've given them. So this is a very good story. And then you can check other features that are correlated. This is now of the amount that was between the amount that was applied for and the credit that was approved based on previous data. Is there any correlation? And this is quite important because we can see if I think there's another graph where we've noticed that the majority of the customers that do come and apply are repeating customers. I think it was over 90% of that. So by virtue of knowing what the customer applied for in the past and looking at the amount that they're applying for now, it seems like there's a strong correlation. So, and this, I bet, will form part of the criteria that a loan financer will use to determine whether they can give a loan or not. So these are very interesting insights. Again, credit that has been approved and annuity. Annuity is the charges that are applied on the loan. The longer the term of the loan, the more annuities you're going to pay. This is good for the loan giver, is not good for the loan borrower. So those are insights that you're making. Annuity and goods, provided you look at the relationship there. So and then here we draw up a box, a stacks box plot there, just also to look at that. But ultimately, we do a correlation plot. A correlation is just a function that's going to tell you which features are correlated. It's basically, it's just an extension of a scatter plot. Cool. So we're just about done. We draw a correlation plot, and where the value is higher, so the value must be between 0 and it must be between 1 and -1. -1 is a strong negative correlation. 1 is a strong positive correlation. So 1 is denoted by that. So these are the features. The count of children is strongly correlated with which feature? Let's see this one. Which one is it? I think I'm actually there. Credit amount is correlated with goods. Amount credit previous there, and I also denote the correlation. This is now for those that are defaulting, and I also did the same thing, I believe. Is that correct? Is it for those that are defaulting, or is this for everything? Payment issue, let me see quickly. Top 10, how did I choose this? Yeah, this is for those that are defaulting, and then I did the same thing for generic as well. And based on everything that we've observed, based on everything, I then do a conclusion. So I specify the top 10 correlation in general, and in my conclusion, I say the typical customer who stands to be approved for credit is 43 years old, is married, lives in a house or an apartment. Tuesday between 10 and 12 p.m. or between 10 a.m. and 12 p.m. are the most productive hours where applications are processed. Cash loans are the preferred forms of products, especially amongst repeating customers with long tenure at the bank. So there is a relationship between tenure at the bank and long and application for cash loans. And I note that we notice that a majority of rejected new applicants are rejected with the error system given as a rejection reason. So that may suggest that the system is down at the time. So I think I've given a recommendation on based on that. We observe that there is no variability in credit approval between females and males. So credit, we don't have any statistical evidence based on the analysis we've done that credit is given different between males and females. So whatever product that you have doesn't have to be gender specific. And then we observe that people who live in household or apartment or municipal, all those get the same but higher credit approval. So it seems like credit where you stay does matter, because for these guys, if you're coming from any of these, you seem to get higher approval credit rating. And we know that this is consistent with what we know. If you're coming from a person who's coming from the rurals and a person who's coming from the suburbs, in terms of positive correlation, what's the cutoff point when it comes to variation selection? Charalo, I'm not sure if I understand that. Oh yeah, I think what you should be looking at is so if there's zero, if the correlation value is zero, it means there is no correlation. If the correlation is between 0 and 5, it means that there is a weak correlation. If the correlation is between 5 and 1, there's a strong positive correlation. And of all those features that have got a strong positive correlation, you should use that. In this exercise, I just picked up the top 10 correlation. So if I wanted to use for my modeling purposes, I potentially will be using these features here.
Can I ask you to just go back to your heat map quickly?
Okay.
Just up a little bit. I just want to see if you have you defined all this the correlation points. Okay, you didn't have. Okay, no, that's fine.
Yeah.
Cool.
Cool. So yeah, for modeling purposes, for feature selection, using correlation, I would use this, but there are other more scientific feature selection techniques that you can use. PCA, for instance, is another, and also sklearn has got a feature selection a function that you can use that can tell you. It uses other advanced techniques other than just correlation, but yes, correlation is one of those that you can use for feature selection. So I would typically pick any features that are between 5 and 1 if I was to use that for feature selection. So anyway, so we were here. It seems like it matters where you come from, and we observed that tenured repeating clients prefer cash loans. So most of the customers seems to like cash loans. And then you go and make your recommendations to them to say, this is what you can do, this is what you may not do, etc. And I think, yeah, that's, in terms of EDA, that's it. I don't know if there's any more questions. Sabelo, I see a hand. I'm not sure who it is. I thought it was Sabelo.
It wasn't me. So with regards to your EDA, right? Because I see that you actually kind of just selected some of the features to explore. So what? I mean, do you do this? Would you do this for all the features, or how do you come about in terms of selecting which features to explore?
So I will do a process of elimination. It depends on the volume, the complexity of the features. In our case, we started with, when we made the files, we had 158 features. it's gonna take a lot of time to go through 158 features, right? So the first thing that I did was I checked of these features that I have, which ones have got the highest missing values. And those that have got missing values over 10%, I deleted those. It means that they contain, my assumption is they contain a lot of noise. They don't have a lot of useful information, right? And then I eliminated those. And then I checked for any duplicates. If there's any duplicates, I'd rather work with one and delete one. So if there's 10 duplicates, I'll delete 9 and be left with one. However, that's going to reduce ROS. It's not necessarily going to reduce features. And then I go, if, for instance, if you look at the documents, for instance, we saw that not all the documents are useful. Some of those documents are not useful because the customers have indicated, like when we flag for each application which document was submitted, we discovered that there's more concentration on some than others. So like for instance, ID came up to be document number 6. It seems like there's a lot of submission for document 6 than all the other documents. So I eliminated all the other documents because by virtue of distribution that I had. But when it comes to correlation as well, I can see that, okay, there's certain features that are not quite as correlated. For instance, let's look at some of the features here with very weak correlation. Look at the previous credit approved versus goods bought for a newly approved. The correlation there is very minimal. I can still, when I proceed and go into modeling, I can decide to eliminate this. So there's a lot of elimination techniques that you can do. The other techniques that we can do beyond this point is we can employ PCA. PCA is going to do dimensionality reduction and all that. So that is answering one part of your question. The other part is, unless otherwise you have information to doubt, it is advisable explore as many of your features as possible. I explored a lot, but I didn't speak for all of them because of time. For instance, I just want to show you. For instance, this is product combination. We've used it, but I didn't say much about it. This is yield, group yield. Yield is basically profit margins. We didn't look at that, but I explored it. Industry sellers, I didn't look at that. Channel types, the type of channels, I explored it, but we didn't touch on that. Product type, portfolio, goods category, there's quite a client type, the different, oh yeah, I mentioned this, but we didn't get into it, etc. So how many are repeaters, new, refreshed, unknowns, rejection reasons, so explore as many as you can, because sometimes we have a hypothesis that things work in a certain way. But when we actually look at the data might be telling us something else. So unless you've got any valid reason, any statistical valid reason to not explore something, then rather explore it and see based on the data that you have, that you've got. Like for instance, when we look at the contact methods, I decided to drop all the other forms of contact, email, telephone, work telephone, and all that, because I realized 100% of our client base said that they've got a cell phone and their preferential method of being contacted to cell phone. So I didn't bother looking at emails and all that stuff. So, and then what that meant was I actually reduced 5 features that I would have otherwise spent time exploring, etc. So I don't know if that answers your question, Soreno. There's another question. You can unmute your mic and speak. Cool. Is there any other comments, questions? Well, if there isn't any more comments or questions, in as far as EDA is concerned, this is pretty much more or less how you approach it as a, and this is something that a data analyst can do using Python. And also this is something that as data scientists we do as well using Python. So what I'm gonna do is I'm going to upload this EDA on the chat, and then I will just share the link quickly. Just give me a minute to do that quickly.
Will you also, in the meantime, perhaps even the case? I think last time you shared the whole use case and whatnot. If maybe possible, you can share it there so that other colleagues can have access to it.
Which one is this? The very same.
Yes, the very same. I think if you can put that, I think I understand there was some wording there, the whole story, narrating the whole use case of what you are. What the case was about.
Oh, okay, okay.
Yes.
Cool. Okay, where's what am I doing now? I want to upload. Okay, cool. Let me do it differently. I want to. All right, I want this here. And I want, there's the use case. I don't want the HTML version. I want the, there we go. Just copy this and I can't paste here. Wow. And when I open it, it does this to me. Oh, okay. Let's do this. I want the detail. Where is the detail? Okay. Date modified. Show list. That will help. That will help me quite a bit. And I want.
If this might be a complex, I mean, maybe it might take you some minutes. I was suggesting that I understand the colleagues. I do have everyone's email, right? You can just do this, and then I'll send an email to everyone latest tomorrow with all these details. I mean, for those who maybe they may want to attend to other things.
I think it's finished uploading.
Oh, okay.
So what I will do is I will just get the link, and there we go. And then I'll put it on the chart. Where is the chart?
Is it possible if you can just make it public, right? Not restricted, like. Not exactly.
Oh, there.
Yes.
Oh, there we go.
And then you just make, and then just the viewers, and then it's fine. They don't have to able to do anything there. Yeah.
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 There we go.
Yes. Okay.
That's done. So there's the link on the chart. Everybody has, and everybody should be able to get their actual Python file and run with it. If you need any, if you have any questions and you need assistance, my email address, I'm just gonna data scientist. There we go. I've put in my email on the chart. There's no spaces. It's just one, datascientist.bax@gmail.com. Just holler and we'll be able to assist you further from there. That's it on my side, Mtlokwe.
Okay, great. Thanks very much, Elijah, and the friends to stick around. I think this was a Ivy League session, right? Thanks very much. So just for the last thing from my side, I'll load this on our YouTube channel. We have a channel called Online Bootcamp with Mtlokwe. Just go there, subscribe, view the previous session, and of course, even these 2 additional sessions that deals with data science. Otherwise, this is our last session for the year. Thanks very much for the support during the course of the year to date, and we are hoping to have a very insightful 3rd edition of Online Bootcamp with Mtlokwe. So please, let's go there, find out the other sessions around cloud, databases, software development, cybersecurity, and the list goes on. So please, we are also quite open to the feedback, being positive and otherwise, so that we can really build this brand. But I'm quite excited to see that we are really doing the real things that are relevant out there. And then through your support, that's where we are here, even this year.
Yeah. And just one last thing, maybe next time we might have a modeling session, because this was just looking at the EDA. So it was a very detailed EDA.
Yeah.
So we might look at how do you then do a linear regression model out of this? How do you then do a classification model out of this? How do you do k-means clustering? How do you do hierarchical clustering out of this? And for each case. So yeah, that's for next time.
Great stuff. So yeah, I will be sharing everything with you, friends, and then let's do it. Let's do this. Have a great Christmas and enjoy your holidays and take care out there. Thank you.
Great. Thanks, everybody.
Yeah.
Yes, guys. Bye.
Thank you. Thank you, guys.
Bye.
Okay, bye.